So, yeah, I am from Winnipeg. Go Jets, go! But my talk really is going to be about how I kind of developed a continuous security pipeline at my company that I work for. So, essentially getting my SAS on, and then essentially my journey of automating security code reviews. So just to kind of give an introduction to myself and how I got to where I am today. So I'm a computer engineering graduate from the University of Manitoba, and I'm about approximately 4 years in the tech industry. I originally started off in embedded systems as a junior test engineer, then somehow found my way in ML at a startup company as a DevOps engineer. And that's where I got most of my DevOps experience, building out cloud infrastructure and maintaining development infrastructure. And somehow I got to application security as an AppSec engineer. So I didn't really have any security knowledge starting off. I honestly didn't even know what XSS was at the time. So I really didn't know what was really expected from me. But my boss was like, that's fine. I'm cool with that. You will learn as you go. But essentially what I want to work on is this DevSecOps movement that he's been hearing a lot in the security industry. And so apparently it's the new hot thing. And he's like, since you have that DevSecOps background, I want you to try to automate security wherever and however you could. Great, I can do that. So I started off looking at how I design CI pipelines, and I noticed that, hey, you have your tests and you push code, they pass, great, let's ship it. And the basic forms of those tests are linters and static analysis because you don't really have to write them, right? You just plug and play. And so I kind of wanted to start off there. So I kind of researched on what security static analysis tools were out there and went from there and decided to develop this security automation service, aka SAS. And essentially it's a static analysis testing framework that will scan on code pushes. And I'll go into more detail in that. But essentially this was the beginnings of my continuous security pipeline that I will go over in this talk. Essentially about my experience, the challenges I faced, as well as how I overcame them. So the first challenge was handling different code stacks. So at my company, they have a microservice architecture. So there's a lot of teams, different processes between teams, and different implementations. And so I had to kind of figure out how to handle all this defragmentation and different code stacks and multiple programming languages. So I figured, hey, let's make my tool modular, plug in all the static analysis tools I know of for security, and determine what tests to run based on what language is for that repository. And you can get that kind of information through the GitHub API. And that's what I used. At our company, we use GitHub as our repository. So that was great. Made it very easy for me. I also went with the open source route, where I used open source static analysis tools. There's a lot of commercial ones, but I noticed that they're a little bit more rigid and not as flexible to configure. So that's why I went with open source, to kind of see how they work the code and then modify it if needed to. So here's some tools I've used in the pipeline. I won't go over each one, but these are pretty standard ones. Like Bandit is a security static analysis tool for Python. And there's Safety, Butler Audit, and NPM Audit that checks for insecure third-party packages. And then I also use GitLace, which is similar to Trufflehog, where it scans for hard-coded secrets, keys, passwords, stuff that you don't want in a repository, especially if it's public. So here's some resources to how I found these static analysis tools. Google's your friend. I also heard a lot of the tools through other people who are in the industry, like Twitter, and then also talks were where I were able to find some tools. So the next one was speed. I needed this to be fast, and fast enough to be in front of a developer to review before the code is shipped. So normally with CI pipelines or CI processes, they're pretty quick, right? You push code, triggers a bunch of tests, and then you're reviewing it in the next few minutes, and boom, it's already out the door in prod. So I needed to somehow figure out how I could fit into that pipeline. So originally I was going to use the existing development CI pipeline, which in this case was TeamCity. But I noticed there were limited workers, a lot of teams are using this, and so queues would be like clogged up, and that just didn't seem fast enough for me. And also each team had their own CI pipeline implementation, so there wasn't really a standard template that they based their pipeline, so it was really hard to scale from that. So I decided to create my own kind of service that did similar to what TeamCity did. So essentially a pipeline that would be in parallel with the development one. So this allowed me to optimize it the way I wanted to. As well with static analysis, since it's I/O bound, I was able to leverage Python async I/O, which is what I based my tool on, for more efficient runtimes. And I'll kind of go in more detail exactly how. So one example of improving speed times was to modify static analysis tools that normally ran synchronously, asynchronously. So what I mean by that was there was this one tool that was written in Python, and when you do a recursive search in a directory, it would scan each file one after the other. And if you have thousands of files, that is super, super slow. So I decided to scan each file individually, but asynchronously. So I would scan what files I need to scan, and then do a gather, and then run those. And so with async I/O, it kind of like is a better task manager. It's not really running them in parallel, like threading, but once it's scanning something, it changes tasks, and then it goes and runs everything, and then gathers those results after. So it was a lot more efficient, and it improved my test times greatly, from 3+ minutes down to 90 seconds, with a repo that had like about 2 million lines of code. So I don't know why I chose 3 minutes, but that was like kind of my goal, was to aim for everything to be tested under 3 minutes. Another way is to kind of scan files that are relevant. Some of these tools are pretty dumb in the sense that they just scan everything. They don't know what it is. They just try to scan it. And so you could search by file extension. So if you're just analyzing Python code, just scan .py files. Also, you can ignore test code. So how my company, most of the repositories are structured, or projects are structured in a way that they have test folder with test code, and then deployment folder with deployment files. So I would ignore those files automatically. And then, worst comes to worst, I limit the test runs down to, as I mentioned earlier, 3 minutes to ensure that something is reported back to the dev. And then any of the slow tasks that timed out, I would review them back and see like how can I improve that. So next up was onboarding teams to actually use the tool. So problem was, how can I get SAS into the development process? How can I get devs to actually use it and have it seamlessly integrated in the dev workflow? So what I did was, I figured, hey, why don't I shove this into the PR process? So pull request process. So I utilize GitHub status checks, and their API is great. You can use that API to import results of any test, and then it'll show up on the GitHub PR. It's just right there as you review the PR. I'll show examples of that. And even better, they introduced this in the checks where you can even annotate the line of code that had that issue that was detected. So here's an example of a PR, and you can see the status checks there. Some failed, some passed, and then as a developer, you see this right away. You're like, oh, why did that fail? Why why, or like, why did that pass, or whatever, right? Or what are these checks in general? So you would go and investigate, right? And then, as I mentioned before, you can even annotate the file changes. So normally when you're reviewing a PR, you go to Files Change, see the div, and boom, right there, you see an annotation saying, hey, this is a security issue. And it's more in the face of a developer, and then since a developer has the context of that feature, it's a lot easier and integrated in the review process, and they can kind of address it right away rather than, oh, okay, let me figure that out later. So on top of that, I wanted to make it easy to install. So I created it as a GitHub app rather than a webhook on GitHub. So originally I went with a webhook where you have to go into the settings, paste in my URL, and then it's good to go. But with GitHub apps, it makes it so much easier to install and onboard teams. Teams can simply just go to the app, and a couple clicks, they have it installed in their repository. So it makes onboarding a lot easier. So in addition to GitHub checks, I provide Slack notifications. That way, as devs work, they can see, they can be notified of these warnings. I also created a dashboard to kind of get an overview of results. So this is great for tracking, and teams would come up to me and be like curious about other teams, how they're doing when it comes to these warnings. And so it's a way to compare as well. And it's great security metrics. Sometimes it's like really hard to measure security, and this is like one of the ways you can measure that. And so just an example, it's probably small font, but on the left axis there, it's number of warnings, and then each line is a repository, and then it's over time. So as you can see, as lines drop, you're seeing that teams are actually addressing these security issues, and you can see the impact of your tool. Yeah, and so there's also future development. Some devs suggested to me, hey, why don't you integrate it with JIRA? That'd be great. It's part of our ticket tracking, so any work regarding a security issue will be tracked in a JIRA ticket. And so why can't I do that just by clicking through the warnings? So in GitHub, I didn't show it here, but in GitHub there are actions that you can assign to the status check, and then maybe you can make that one of the JIRA integration create, and then boom, creates a ticket for the team. So that's a lot more integrated as well. Also providing a process to ensure warnings are addressed. So with bug bounty, you have kind of a triaging process, seeing if this alert, seeing what the severity is for this issue, and then setting an SLA. So how long do you have to address the issue or fix it? So it's a high priority, let's fix it in 7 days. This gives a little bit of urgency to the warnings as well as accountability. So this is a resource on how to use status checks from GitHub if you're interested in knowing how that works. And then the next hurdle was getting leadership support. So with any initiative, sure you can educate devs and whatnot, but if it's not coming from the top, it's really hard to prioritize that work and get support from it. So I've had devs come up to me and say like, hey, I would love to work on the security issue, but I have this, and they have no clue about this, and they're not going to prioritize it. So I realized, okay, I got to educate the management and execs. So how exactly would I get that support and have them drink the SAS Kool-Aid, essentially? So just security awareness, like this is just basic code quality. You're trying to improve code, you want to secure it. You also got to educate on the consequences of deploying insecure code. There are data breaches, they have money associated with that, fines, it's expensive, like it's not really worth it when you could just simply upgrade a package or rethink something, right? And also I mentioned that, hey, SAS can be extended outside of security tools. It's not just a security tool. You can use it for other linters and other tests that you want to build out. It can be used for engineering however they want to use it, right? So it's kind of a joint effort. And then the biggest criticism when it comes to static analysis, and I got this from management and higher up saying like, but what about false positives? That's not credible, like that's just a waste of time. So I knew I had to address this. So how exactly did I reduce false positives? So I tried to turn off tests that weren't really needed. So for our use case, we use Python, and Bandit would issue a warning whenever it sees assert in the code. And assert is normally you're validating something, right? So the moment that's gone, your validation is gone, and there's some sort of bypass. So it is a valid warning, but that is removed only when you compile to optimized bytecode. And well, we don't compile to .py, right? So I was just like, okay, I hear you, team. A team brought this up to me. I was like, I hear you, let me turn this off. You have a valid reason. And so that reduced a lot of noise for teams, and they were able to proceed and actually view these warnings. We need to be able to enable devs to flag false positives themselves, make it easy. I know Bandit and some other internal tools, you can kind of comment the line of code, and it will ignore it. Of course, you don't want to abuse this, right? We got to educate devs that like first think about it, is this really a security risk, and then put it in. But that's the knock with static analysis, that it doesn't have that context, right? And that's why this is like a good way to encourage devs to have that security conscious mindset. So also you can just have tools that check for insecure third-party packages. Those are most likely not false positives, and they're easy to address, just upgrade, right? So that's one way you could go about it. Just have these tools and then slowly amp up to other tools that maybe fit your use case. So kind of just to recap, if you're thinking of making some sort of continuous security pipeline, make sure it's flexible, especially when the system is very complex, right? There are going to be many different use cases, so you need to be able to adapt and configure accordingly. Also, it should be fast. Like I said, it's more impactful when it's reported before the code is deployed. The moment it's deployed, devs forget about the feature they made, and it's really hard to address warnings afterwards. And next, make it easy and intuitive, so it's not more work for a dev. It should be part of the development process, and kind of encourage devs to be security conscious and have these discussions. Like, they don't have to be experts about this, but it should get them questioning. I had one dev that's had this tool installed, and they saw a bunch of SQL injection warnings. They're like, well, what does this all mean? Why? And then so they Googled it. They like looked it up, and they realized, oh, don't do string interpolations. I should be parameterizing my queries. And then so they did that, right? So it's like an education. It's not someone telling you what's wrong. It's providing you insight, right? So just empowering devs to have that security culture, right? And also, I developed it for the teams, right? So you're not paying some third-party commercial tool to do it for you. So it shouldn't be considered a waste of money or something like that. It just requires time and attention, maybe, and education. But yeah, that's pretty much it. Thank you for listening.